Alright, so the purpose of this screencast is to show you how to use Logger Pro. It's nice software that we use a lot to graph and analyze data. Let's get started. I'm going to open up Logger Pro. Looks like this on the Mac. And let's see, maybe before this point you would have maybe done a lab and tried to investigate a question. The graph is really showing you a relationship between two variables. Right now they're shown as x and y. So I'm going to make up some fake data that address the question, how does age affect weight? So we seek a general mathematical relationship between the variables age and weight, and now we're going to graph age and weight and see if there's a relationship. I'll double click on where it says X under data set on the far left, and my first variable I will put age. It doesn't matter if I start with weight or I start with age. You can always change the way the graph is presented, so it's very flexible that way. And I like using the tab button rather than clicking to the different windows. If you press tab, it takes you straight from name to short name. And short name, for age, you could write age, and the units would be something like months, and then I hit return. And you'll notice this column is labeled with the variable age and the unit months. And now we'll double click on the Y column, and I will call this column weight, that is the variable weight. Under short name I'll write W, and the way I measured weight, let's say, is pounds. Then I hit return, and my graph is labeled with variables and units in parentheses, which is nice. And I'll just make this data super simple. 1, 2, 3, 4, 5, 6, 7, 8. And the way I'm moving is I'm pressing up arrow, down arrow, up arrow, down arrow, and I can just fill the column in all at once. I can even use the arrows to go to the right and go to the next column. So now I'm at the top where it says weight, and corresponding with 1 month age, let's say I have 7.3 as the pounds that were measured at 1 month, and then it might be 9.4 at 2 months, and 10.5 at 3 months. Now you'll notice each set of a number that represents an age and another number that represents a weight, that's called one data point. So it takes two measurements, a measurement of each of the two variables, to give us one data point. So 1 month, 7.3 pounds, 2 months, 9.4 pounds, 3 months, 10.5 pounds. That's now 3 data points. Now I'm on my 4th data point. I'm looking at about 12 pounds at 4 months. And at 5 months, I'm talking 13 pounds. 6 months, 14.3 pounds. And then 7 months, 15.2 pounds. And finally, at 8 months, 16.7 pounds. So this would be our data. And I'm going to move these words over so they don't block my data. And see here. Now, if I double click on the graph, you see how a window pops up? Okay, so that's double clicking. Another way is to go options, graph options. It's the same window. I'm going to get rid of these XY error bars. They don't really do much for you. If this is connect points, if that's ever checked, you want to uncheck that. The only thing we usually check here is point protectors, which tend to make it easier to see your data. It puts these little circle things around our data. And under axis options, I'm going to do auto scale from 0. Okay? And that's good. This part of the window is the horizontal axis, otherwise known as the x-axis. And this part of the window is our vertical axis. People usually call that the y-axis. I like to call it the vertical axis. You hit OK. All right? And then, I'm going to get rid of this. This is in my way. Then I'm going to grab the edge of the axis and drag it to stretch axis. And I'm going to hold the minimum value constant when I do that. If you drag from down here, my vertical intercept, it's all screwed up, dude. Look. Now it looks like my graph comes down at 0, 0. It doesn't. So I hate it when that happens. I like 0, 0, the origin, to be at this corner. It confuses my brain when you change that. And if you grab here, same problem. Now my 0, 0 isn't right there. So I'm going to fix that now by undoing all those. Now 0, 0 is truly this corner. And I can see that if this data were linear, grabbing the axis from the edge is good, because now I can see this guy. See, that's pretty good. Another thing I should do is I double click here and I can change the color. You know, you can print in any color you want in my classroom as long as it's black. That's all we got. Another thing you can do if you go to that window is you can change it to filled circles. That's probably good. Then you can see your data. You just want your data to look nice. You want to present it in a way where it's easy to understand. Now this could be a curve or it could be a line. I mean, you know, it could be looking like that. Or perhaps it looks something like that. The answer lies here. One of those will make more sense than the other. Like, at 0 months, having 0 weight doesn't make sense if it's a human. So I think it's probably not a curve. So I'm going to highlight the data. And up here there's a button called Linear Fit. If I click there, it puts a trend line on your data. It makes a line that best fits your data. This line doesn't have to go through any of the data points, but it's a trend line. It's a best fit line. The other way I could do it is I could go Analyze, Linear Fit. Either way works fine. And then I'm going to move this box over to a convenient spot where it's out of the way. It doesn't hide any of my data. That'll work. That looks pretty good. Cool. Now you're going to take this information that's in the window. Now maybe you'll start here. What does that W stand for? Well, remember those short names you put? There's your W. Stands for weight. So if you labeled everything, it's going to be easy to figure this out. You just want to write out the words. W and A stand for weight. And then I'll write the equals. And then the A is written over here. But there's an M here. There's a lowercase m. the lowercase m here stands for slope. And you simply write the number here with the units. And I wouldn't write it like the way it's written in this box. I would make sure my denominator says 1 month. It's just easier to understand. And then the numerator, you can round it. It's like 1.3 pounds. And then our intercept is added to the end. So you've got 6.6 pounds. All right? And this number here, the 0.99, the closer that is to 1, the better your data fits the best fit line that the computer has drawn. At this point, we're going to take our intercept, which is right here, and try to understand it. See if it makes sense. Now, this point on the line, where the line intercepts the vertical axis, it happens at 0 months. So, when age, and I'm thinking this is a human baby, when age of baby is 0 months, the weight, baby's weight, was about 6.6 pounds. There we go. About 6.6 pounds. If that makes sense, you're in great shape. Now, the slope, the 1.3 pounds per month, should also make sense. Since the denominator says 1 month, you can start off by saying, for every month, for every increase in age by 1 month, comma, baby's weight increases 1.3 pounds. So, going back to our original question, what was our original question? How is age related to weight? And I'm guessing this is for a human baby, so I'll add that in. You would definitely want to do your title on this graph after the fact. You don't need to write the title before you make the graph. So you could say it like that, or you could say, how does age affect weight? It's the same thing. In any case, you've got a beautiful answer that actually describes how much the weight's increasing for every month that passes. And you've got an actual weight at birth that makes sense. So I think you're in good shape here. That's it. That's a nice example of how you can use Logger Pro to not only graph your data, but make sense of your data. And I appreciate you watching. Have a good day.